In today's note, we're going to be looking at a review of skills that we should remember from grade 9 and that are going to be useful as we go through this course. So in example 1, we want to evaluate. And when we see the word evaluate, what this is basically telling us is that we want to solve the following expression or equation. So in this case, I have 6 minus 2 divided by 9 minus 3. So as I'm solving equations, the overarching thing that I want to remember is BEDMAS, brackets, exponents, division or multiplication, addition or subtraction. But when I have fractions like this with something on top and something on the bottom, what I want to do is I want to simplify the top and bottom first. That's what I want to do. I want to make sure I simplify the top and the bottom first. So in this example, I can do 6 minus 2 first, which is 4, and then I'm going to divide that by 9 minus 3, which is 6. But what I can do now, while this is the right answer, I want to make sure that I try to reduce my fraction as much as possible. And it will become useful later on, but I want to reduce my fraction. Right? I reduce that by dividing it by a number that is common, or the greatest number that is common between both of them, or greatest factor. In this case, it is 2. So when I divide both numbers by 2, I get 2 over 3, which is my final answer. In example B, I'm doing the exact same thing. I'm going to solve or simplify the top and the bottom first, and then I'm going to reduce my fraction if possible. One thing you want to keep in mind, when you see something like this where it is a minus or a negative and a negative, that actually becomes a positive or becomes addition. So this becomes positive. So I can rewrite this as negative 5 plus 3 divided by 2 minus 4. I'm going to simplify the top and the bottom. Negative 2 over negative 2. And then I'm going to reduce this. In this case, I can divide both numbers by negative 2, so I get 1. Or I can just do negative 2 divided by negative 2. Again, the fraction just means division. In example 2, I want to evaluate if x equals negative 2. So again, we know evaluate means solve. And when I'm given what a variable equals, like here x equals 2, this means I have to sub into the equation. So I need to take the number that I'm given and substitute it into the equation. So in example A, 3x plus 2, instead of the x, I'm going to replace that with negative 2 plus 2. So this becomes 3 times negative 2, negative 6 plus 2. And now I'm just going to add these two numbers. So negative 4, which is my final answer. In B, it's the same thing. Instead of x, I'm going to substitute in negative 2. We talked about this double negative on the previous example. So if I have these two negatives, I can rewrite that as 5 plus 2, which equals 7, which is my final answer. In example 3, when I want to solve an equation, which is what I have here, I want to find what x equals. Or in other words, I want to isolate for x, or get x by itself. So if I look at my first example, x minus 7 equals negative 5. Again, this may be something that's straightforward. You might be able to look at it and figure out what x actually equals. But if not, we have to kind of work through using algebra. So if I want to get x by itself, I'm going to put a bracket, or a box, around this negative 7, because that's what I want to get rid of. So if I get rid of the negative 7, or in order to do that, I need to add 7. If I do the opposite of whatever I see, so we can think of opposite operations. if I do the opposite of what I see, that will help me cancel it out. But if I do one thing to one side, I need to do the same thing to the other side. So I need to balance everything out as well. Because by balancing, I keep my equation the same. So it cancels out on the one side, because if I minus 7 and add 7, it cancels out. So I get x equals negative 5 plus 7. I get x equals 2. That's my final answer. Now another way you could think of it, rather than drawing the box, if I have x minus 7 equals negative 5, I could think of it as moving the one thing to the other side, and when I move one thing to the other side, x is by itself. I still have the negative 5. The negative 7, when it gets moved over, it changes operations, so it goes from minus 7 to plus 7. I get x equals 2. So 2 different ways to think about that answer, or think about that problem. If I want to check my answer, what I have to do is I have to sub the answer back into the equation. So very similar to what we've done in a previous example, I know that my answer is x equals 2, so I'm going to take that answer, so x equals 2. I know my original equation was x minus 7 equals negative 5. I'm going to take my answer and plug it back in, so instead of x, I'm going to replace it with 2. 2 minus 7 equals negative 5, based on my equation. 2 minus 7 equals negative 5, which does in fact equal negative 5. So left side equals right side, negative 5 equals negative 5. That means my answer is correct. If I look at example B is similar. There's one added step. So B is 4x plus 3 equals negative 9. I have 2 things to move. I want to move the separate term first. So I want to move separate terms first. So in this case, I need to get rid of this plus 3. So I'm going to draw a box around it. To cancel out plus 3, I have to minus 3. To keep things balanced, I have to do the same thing to the other side. On the one side, it gets canceled out. I'm left with 4x equals negative 9 minus 3. So 4x equals negative 12. Now, in order to cancel out this operation here, or 4x, we have to keep in mind that 4x is another way of saying 4 times x. So if I want to cancel out multiplying, I need to divide. So in this case, I'm going to divide by 4 on the one side. I need to divide by 4 on the other side as well to balance it out. On one side, it'll cancel out. I'm left with x equals negative 12 divided by 4, or negative 3. And this is what I claim to be my final answer. If I want to check my answer, again, I can do the same thing. I have my original equation, 4x plus 3 equals negative 9. I'm going to take my answer of x minus 3 and substitute it in. So instead of the x, I'm going to have minus 3. So 4 times negative 3 plus 3 needs to equal negative 9. Negative 12 plus 3 should equal negative 9. And I get negative 9 equals negative 9. These two numbers are the exact same. Left side equals right side. So this is my right answer. So again, from this note, we're just looking at a review of kind of solving equations, evaluating, and checking our answers.